We're going to now take a look at partial fractions. And in order to understand what partial fractions are and what partial fraction decomposition is, we really need to take a look at how to add rational expressions. So we have these two rational expressions. It looks like we're subtracting them, and again, we can certainly leave the subtraction. I'm going to go ahead and change it to adding. So basically we are adding two rational expressions. So in order to add two rational expressions, we know that it's real similar to something like this. Back in middle school, when we had to add two fractions, we know that we had to get a common denominator. So we would know that we would multiply both of those by 3 and both of these by 5, and that would get us our common denominator. But it's no different at all with rational expressions. What I'm going to do is make sure that both of these have the same denominator. Well, they have to both have the same, basically same factors on the bottom, right? Kind of like the 3 and the 5, they both had to have a 3 and 5 present because there was a 3 and 1 and a 5 on the other. So I'm going to go ahead and give the left-hand side its own x plus 3 because it didn't have that on the bottom. But in order to make that legal, it's actually kind of like I'm multiplying this left-hand side by a funny form of the number 1, because that really does equal a 1. So it's legal to multiply just a random fraction by 1 anytime I want. And that's the reason that we can do what we're doing, is I'm multiplying really by 1. So let's take a look at this one. I'm going to multiply this one by a funny form of a number 1. Alright, so let's see what we get. We have 4x plus 3 plus negative 1 x minus 2, and both of those now have matching denominators, right? That's pretty simple. And x plus 3, x minus 2. Now you don't want to go and cancel the like terms, right, above and below, or excuse me, the common factors above and below. Like we don't want to cancel this with this because it would go right back to what it was before. So don't get tempted to do that. What we want to do is we want to combine the fractions, right? So I'm going to get this into one fraction. There's the common denominator that allows me to do that. So now I have 4. I'm going to go ahead and distribute this. I don't think anybody will mind that. And then I have a negative y plus negative 1x, and then I have plus 2. Okay, so we finish this up by just saying, okay, let's get our like terms together on the top. Don't ever combine the bottom. Don't ever multiply out the bottom. Just leave it. Always leave it like that. We're just going to leave it alone. Okay, there's that. And it looks like this is what I get. And there we go. No big deal. Alright, so there is the answer, okay, to adding those two rational expressions. So let's take a look now. Here's what, let me go ahead and tell you what partial fraction decomposition is. What it is we take this answer and we actually calculate what were the two things that we had to add together to get that fraction. In other words, we're decomposing the fraction. Pretty interesting, right? So let's take a look at how we do this. Alright, so here's the equation that we're going to start with. It says find a and b for the partial fraction decomposition. So again, we're going backwards, trying to figure out what in the world would we have to have had at the top of this fraction and at the top of this fraction, right? In order to add them together and get this, right, after finding a common denominator, right? So what we're going to do is, believe it or not, this is actually going to become a system of equations. So that's what is interesting about this partial fraction decomposition. Well, I'm going to just solve this problem. I'm looking to solve for a and b. So let's see how we do it. We're going to get rid of the fractions completely by multiplying by the least common denominator. Okay? There it is right there. Now, I'm not multiplying by a funny form of 1. I'm actually multiplying both sides of the equation. Notice this is an equation this time, so I can multiply both sides by the same thing, and it's legal. So let's go ahead and do this. We're going to have this multiplied, we're going to have this right here, this left side multiplied by the right, and what's going to happen is we're going to have all of these cancel. Right? Don't distribute them or multiply with FOIL or any of that stuff. We're just going to cancel things. So we have 11x plus 4. You're going to get rid of all of the denominators, right? So let's take a look at this one. Let's distribute this one right here. When I take a look at distributing that to that, then you can see that the x minus 1's cancel, and all I have is this, a x plus 2. All right, now we're going to distribute it to this one. Now we know that it goes back to what it was before, so that we have all the parts, and we look at what's going to cancel now with the b term. Well, it looks like that the x plus 2's are going to cancel, so we're going to have b x minus 1. Alright, so when we do partial fraction decomposition, we make sure that we have the a and the b separated, and we're not going to do any that are a greater degree than just these, so we're only going to have an a and a b in ours. What we're going to do now is we're going to get rid of the parentheses, so that's the next step. Okay, you're going to make sure that you're let me back up a bit. You're going to make sure that you get rid of the denominator, all right, by multiplying through by the LCD, least common denominator, and then we're going to get rid of the parentheses. Let's take a look at that step. AX plus 2A plus BX minus b, and that's equal to 11x plus 4. Alright, now let's take a look at the last thing that we do. Not the last thing, pardon me. One of the key things that we do is this. Now we're going to take like terms. These are like terms, and I'm going to put them together. AX plus BX. Put all the other stuff at the end. There it is. Okay? Leave the left-hand side the same. Now here's where it's really cool. We're going to factor out the x, but I'm going to put the x at the back of it. So watch this. I'm going to factor out the x. There's a common x, right? And then I'm going to leave everything else the same. Now here's where the colors help. We're going to take a look at some highlighting here. So here I have this. And I'm going to kind of change up my color situation. These are not necessarily related to the original colors I used. But would you look at this position right here on the right side, and look at this 11 on the left side. If you look carefully, you realize that the number that in front of the x is this a plus b on the right side. The 11, that position, is in the same position as the a plus b on the right, sitting right in front of the x. That means this. That means that we're actually going to take that and we're going to write an equation from it. Okay, now here's what's just as cool. This right here, the one that's after the plus sign, doesn't have an x with it, is this. So we're going to create an equation from that. So we have 2a, and you can see, oh my gosh, already, you can see this is a system of equations. Now I'm going to rearrange the order because our brains like to see it the way we're used to seeing it so that they'll recognize what to do. Now, do you know what to do? Of course you do. This is a system of equations, okay? And we're going to go ahead and use elimination because it's already set up very nicely. So I have 3a is equal to 15. I get a is equal to 5. Let's put it back in this top one here. If I have a is 5 plus b is 11, then I'm going to have that b is 6. Now let's go back to the original problem and look at a, putting in a for 5 for a and 6 for b. So this right here is 5 and this right here is 6. And if you went and added these two fractions together after getting a common denominator, it indeed would be this fraction right there. Alrighty? Pretty amazing, huh? Thanks for watching.